In this video, we'll attempt to look at finding the stresses, the radial stress and the hoop stress, using the concept of strain. Alright, so normally in this particular case, there is a certain cylinder, right? And then we look into this direction. When we look into this direction, we will have a circular ring like this. Alright, and there will be a certain stresses that is acting along this, and then certain radial stresses, if you still remember. Alright, and instead of looking at stresses, we look at the strain. Alright, there will be a strain pulling in this direction. Alright, we call this U. Okay, and we have a U plus du. Okay, because if you pull in a certain U, you'll have a certain small reaction force U plus maybe a little du that we assign to it. Alright, a little small du over here. And we are still looking at in terms of static, where you just put it there and then you just let it go. And however, now we also have a system like this. Alright, this is a small changes of R. Sorry, it shouldn't be here. This is your R. Okay, is it my R over here? Okay, my R actually extends throughout. Okay, my R actually extends throughout all this. This whole thing is R, from the origin to the end. Or is R, and this R multiply with a certain angle, or maybe there's a certain angle over here. We call this theta. So R times d theta will give us the arc length over here. Alright, there will be changes in the arc length. So R d theta is this one. And the changes, I would say not changes, but rather than when you apply over here is R d theta. And when alternatively, if you apply in the reaction force direction, you have a little small u over here instead of the u. Alright, this is the part I just keep it first. Alright, just have a small displacement over here. So I'll have R plus u d theta also. Alright, there will have a certain angle over here. There will also have a certain angle over here. Alright, but they are in terms of the radius. Alright, so you're talking about the because your arc length over here is talking about this length. Alright, if you have R plus u over here, you're talking about somewhat extending onto this length. So when you pull onto this side, you're gonna have this two strains over here. Alright, but in terms of how do I say? In terms of this whole thing, okay? So this thing over here is R d theta, while this thing over here is your R plus u d theta. Alright, but because we split it out into two parts, I just want to convey in a more clearer way. And then now equilibrium of strain, alright, is only by sector. Alright, if you talk about only u and u plus du, this means you're talking about this thing over here. Alright, this is still your dr. If you were to extend, this is just your circle, your ring over here. Alright, your ring, if you can visualize, yeah, like that. Okay, so if I zoom in, I'll have this piece over here, and then we have this thing going here is a plus, going here is minus. Alright, so therefore this u plus du, alright, minus u, because there is a u going in this direction, certain strain. Alright, and we know that what is strain? Strain is, let's say we have an original length over here, and you pull it by a little certain extension, this delta naught. Alright, so delta naught over L naught is equals to your strain. Alright, so the little changes in our case is the du, right? Because u and minus u will cancel each other, we have du. So du is the small little changes that happen across dr, this particular length. Alright, so we will have something like a du over here. Alright, so hopefully you understand. And therefore this explains your strain R in your radial side is du over dr. Okay, now what about the strain theta, I mean the hoop stress, hoop strain, you would say. For this hoop strain is a little tough to visualize, or as I have explained, it's a little weird. Well, let's just explain again. Is there is a certain angle theta over here, alright, and this has a length of r, right? So r times d theta, alright, this is the angle theta, will give you a certain arc length over here. Alright, so if I were to extend, this is my arc length of r theta, r d theta. Okay, then which is over this side. Alright, if I were to pull from these two directions, alright, this will actually cause this to happen. However, due to a reaction force against both sides, alright, reaction force against this both radial hoop strain, alright, there will be a small little r plus u going on. Alright, so this r plus u, which we'll be talking about this thing over here, this is the u. So r plus u is simply this is r, so r plus u is simply this line over here times d theta, so it's r plus u d theta. Okay, so your reaction arc length will be something like this. It's going to pull in this side, it's going in this direction, right? So this particular one is going in this direction, while this r theta is actually this one. Alright, so when you pull in this direction, you're gonna have this r d theta. So the reaction force from this side will actually cause a restriction, alright, the reaction force that is going to pull in this direction. Right, this is a bit chim, right? But anyway, so if you pull into this direction, this is r plus u d theta. Alright, and minus r theta is simply going in this direction. So therefore I have this over here. And then you multiply it in, alright, you will have r d theta plus u d theta, and then r d theta and this minus r d theta will cancel out. What you have is u d theta, r d theta, alright, so the theta cancel out, you will have u over r. And why is this r d theta over here is actually still talking about the original length. The original length is actually r over here, right? R plus this is actually a small changes of u, right? This is actually a small changes of u. Right, we're talking about a small changes of I think you get what I mean already lah, huh? Yeah. Now if you still remember your Hooke's law, although I didn't remember, but it's just this equation, this long chunk, something like this, right? But because this is 3D, what we are doing is 2D, so we actually have some difference between that, so it's not using this. But this is 3D, but at least you know that there's a link between what we have studied and what is using right now. So I can simply sub in this, instead of strain 1 1, I can sub in as strain so-called sigma RR and sigma theta theta for this case. Alright, this is our Hooke's so-called hook strain, and this is our radial strain. Alright, so du over dr, in fact there is an error over here, is that this is actually RR, this is theta theta. Alright, because our strain RR is du dr, this is du dr over here, but what he write is, instead of RR, he write theta theta. Alright, just take note of here. So just simply sub in this du dr is equals to 1 over e, alright, sigma RR minus sigma theta theta. This is an equation that I will highly recommend you take down, because for 2D system. Alright, same as for your strain theta theta, which is over here, u over r is equals to this one. You just simply sub in the stuff study. So if you have a r over here, this means that sigma r is positive. If you have a theta theta over here, this means that sigma theta theta is a positive, and the rest is negative, and that's it. Alright, just for you to notice, note. Alright, so how do you change to stress now? Since we have a strain, we can use, because we want to find strain, right? The strain, how do we find strain? So we just simply sub in over here. What you do is rearrange only. So I'll just bring the e outwards. Alright, what I have is e du dr, okay? Then is sigma rr minus v sigma theta theta. Alright, then I bring this to the other side. I will have e du dr plus v sigma theta theta is equals to sigma rr. Never mind, at the end of the day I didn't actually get the same answer. Alright, but at least this is something of a rearrangement, then you will get this one. Alright, but this is in terms of something that we oh yeah, okay, can hold on. Right. We know that sigma theta theta, alright, this thing over here is our u over r, right? Sigma theta theta is equals to u over r. So I can just sub in as this one as u over r. Alright, so I have vu over r over here, and then I have a du over dr, and then this, to some extent, this Young modulus somewhat have some magic to that. I don't know what the hell, but something there, alright, something there. Because this is why I say that I'll briefly go through, even if I didn't say so, but I'll briefly go through. Then we have our equilibrium equation that we derived earlier, although we didn't fully derive it. And then we have our stress over here as sigma rr and sigma theta theta, which is what we have done just now. Alright, although we haven't done fully yet, because I'll only tell you that in terms of the sigma rr. Alright, but in terms of sigma theta theta, the method is also about the same. Alright, but there's something that we don't understand about the Hooke's law. This is why I don't know how to do it. Alright, then since you have this stress over here, you just simply sub it in over inside. You have this sigma theta theta, you just simply sub it inside, or your sigma r also sub it inside over here. Once you sub everything inside and rearrange very nice, you'll get this thing over here. I'll not go through with you because it's really very hairy. And then after that you do some solution and use Laplace, or you can use whatever thing. Alright, this is just some u equals to c1r plus c2 over r. And if you just take a look, this is very similar to your the general equation that we have derived. Not derived, but rather than show you just now. Is a plus b over r squared. This one over here is somewhat the same. If you take a look, it's actually u is equals to c1. If you divide everything by r again, alright, this will be u over r is equals to c1 plus c2 over r squared. Alright, something like that. You have to remember u over r is your sigma theta theta. Alright, so you can just simply somewhat relate the u over r as your strain theta theta. I mean stress theta theta. So therefore you also can see that over here stress theta theta is a plus b. However, we have c1 plus c2 over r squared, something like that. This is the same if you were to apply for certain understanding to get this. So I think this is a good understanding to derive to a visualization of how these two general equations are being derived. Alright, but I'll just not go through it in terms of a very deep way, but touch and go. And then since we have this u over here, then you can just simply sub it into your du over here and your u over here. So you just simply sub back into your sigma r and things like that, or your sigma stress. Alright, what you have will be somewhat this stuff over here. Alright, this stuff over here. And then this is in terms of some c1 and c2. So you need to use a equilibrium. I mean, what's that called? Yeah, some equation. Alright, simultaneous equation. Yeah. And then you sub in your boundary condition as we have done earlier in the minus pi and minus po with the pressure outside and the pressure inside. And then you just simply sub it in. Therefore, instead of that, you have sigma rr as minus p in or minus p out. Alright, and then your radius over here will be either radius in, radius in or radius out. It depends on what radius you sub in. Alright, once you do that, you'll get something like this, your c1 and your c2. Alright, then once you get your c1 and c2, then you can just sub in back into your equation. This is your c2, right? So I'll just bring it. Yeah, this is your c2 over here. So you sub in your c1 and c2 back into this equation, and you can get the equation for your stress. And this is a very, very hairy, super ultra ultimate hairy formula. Alright, and you go get this one, your sigma r and sigma theta theta. And then sigma zz is something that we have done earlier previously. I will not go through over here. But this is something that you understand in terms of strain, and in fact this equation, at the end of the day, I will realize that this is actually deriving for our general equation for this thing. Alright, and just to take note is that this whole stuff over here, they are all Lemans equation. Alright, and that's it. This is your stresses derived in a different way. See you soon.